programmer on the team. And then
I'm Kira. I'm one of the drivers for the team.
I'm Natalia. I'm also one of the drivers for the team.
I'm Mila, and I make the engineering portfolio for the team.
I'm Angela, I'm also.
So what is FIRST?
So FIRST is a global robotics community that works to introduce students to a STEM education, and it pushes an emphasis for gracious professionalism.
So there are 3 types of FIRST robotics challenges. So the first one is FIRST Lego League, which focuses on a really a younger age group and introduces them to robotics using Legos.
The next is FRC, which is essentially the FIRST robotics competition, and it's kind of like FIRST, but to like a larger level for like FTC. So FRC is essentially an extremely competitive robotics competition for high school students.
And then lastly, we have the FIRST Tech Challenge, which is what we compete in. It's sort of like in between Lego League and FRC. It's more of like middle and high school students. It revolves yearly, and yeah, different challenges each year.
And then why FIRST? Why would you want to join a robotics competition? So FIRST prepares students for like the STEM field. Through FIRST, it's really easy to gain new skills and interests in the STEM field. And FTC specifically is an amazing way to dive into robotics because it's more advanced than FLL, where you're using Legos, but it's sort of the middle ground between that and FRC, which is really advanced and more for like people who already have skills in robotics. And so FTC is a great way to take that first step into the robotics field. And FTC sharpens your collaboration skills because it's not something individual, it's with a team that you work with. And FTC also allows you to connect with different communities. Since FTC is like global, like other FIRST programs, you can meet teams from all around. I know in our competition, so even though it was only like mostly SoCal teams, we got to meet teams from like different areas in California that we hadn't met before. Okay, yes. So on the idea that FIRST and FTC lets you learn so much, this is our robot for our competition this year. Our competition season is already over, but this is what we worked on throughout the year. We took a lot of initiative this year with making a lot of 3D printed parts, which is something a lot of us hadn't done. And I know our main 3D printer has done a lot of work, and it was a lot of trial and error to get this right. But because of the way that FTC is structured, it was really easy to be able to go through that learning process and learn so many new things when it comes to robotics through this competition. And then, how do you start an FTC team? So first, you have to find people that are also interested in robotics. For us in our school, if you're interested in robotics, there's a class where you can usually sign up for. But I know other people don't have that. But once you find people that are interested in it, and you find a mentor, which is just any like adult figure in your life, like a teacher or a coach, that is willing to put in that time commitment, you can go to this website where your mentor can register and to start a team. Another very important step is finding grants. Like there's many places that give rookie grants, which is like grants for newer teams, and they will be willing to pay for your registration fee. Some grants even give you extra money so that you can buy equipment and get starter kits. I know we're not a rookie team, but there's still grants for continuing teams that helped us pay for our registration fees. And then buying equipment is really important. We really recommend looking into the starter kit for your team because they come with all the materials that's necessary for you to be able to take part in the competition and for you to be able to grow past like just the starter robot. And then finally, brainstorm and find more mentors. Brainstorm what you want to do in the competition, what you want to achieve, like what your goals are for the competition. And find more mentors. Find people who have been in FTC teams, who've graduated. Find mentors who are maybe just in the robotics field who can help you learn more about those specific goals and those specific fields in robotics that you're interested in. And then how to manage an FTC team. So we've been an FTC team for 4 years now.
Yeah.
And so we've got a lot of practice in managing this. A great way we have learned how to manage an FTC team is to form sub-teams within the robotics sphere. We have a programming sub-team, we have a driver sub-team, we have a builder sub-team. And this helps us stay organized and have that one person that we know when something's going on with building, we know we can go to that person. When something's going on to in programming, we can go to that person. And our driver team is specifically because in the competition, we have the field is set out and there's two parts of the competition for FTC. There's an autonomous time and there's a driver control time. So in programming, you have to have one program. Usually you have one programmer or one teleop programmer, where one programmer focuses on your autonomous movement and the other one focuses on making sure that the gamepads control to the robot and the gamepads are able to tell the robot what to do. So our driver team focuses on practicing movements using the driver controllers in order to be able to seamlessly go move around the field and score points throughout the match. And that's why it's really important to have sub teams, because we can have certain people who are really skilled at doing certain things like driving and other people who are skilled in building, which can help between matches in case anything goes wrong. And then a really important way to also manage an FTC team is make sure that team members can explore their interests, that they're not just stuck within one box of what to do. I know we've really focused on this year by advancing what we usually do. Last year, we stuck more to traditional, having staying to the same methods of autonomous and teleop, which is driver controlled, within the robotics sphere. But this year, we advanced that and we tried new algorithms with programming and we tried new building stuff. And we have, and it's when we start to implement 3D printing within our robot. And another way to manage an FTC team is to keep team spirit high. People don't want to feel like they're coming to robotics and it's another responsibility that they have to do. They want to come to robotics and it's like a relief. It's something that they want to do, something that they look forward to. So in order to keep a team going and so that they won't lose interest, is to keep team spirit high. Have consistent meetings, have specific deadlines, have specific goals, but don't make it like a burden on team members. And then on that note, set deadlines and goals to accomplish for the game season. For us, we set specific deadlines for when we want a specific build done, and then we have other deadlines for when we want autonomous done and when we want our driver control done, and then we have specific time set aside to practice that driver control, which is really important for us. And then that's it for our side of the presentation. We also want to focus on answering any questions you guys have about FTC team, because I know it's a really niche topic that might not be covered by just statistics and logistics. It's something that can be really personal. So we love to just talk and answer some of those questions.
Great. We have questions already in the chat. I'll start us off with those first. The first one was from Alex. What kind of 3D printer are you using?
So I have to actually check with our 3D printer, but we have one Airwolf 3D printer within the classroom. That's our schools. And then our 3D printer actually has her own 3D printer at home, which sometimes is helpful, especially for 3D prints that take a long time. Sometimes they take 8 hours or 12 hours. So it's really helpful to have it in a separate school site outside of school so that it can be accessed at different times, even when school is not in progress.
And a follow-up question from Alex was, what programming language is used?
So it's Java, but there's different options. So there's on-bot Java, which is what we use, and it's written Java. And then there's a block version of it where it's block text, but still Java. And then there's another version where you download software onto your computer and use it. It's called Android Studio. And then I'm pretty sure that's still Java, but it's just on a different software level. It's kind of set as if your complete introduction to coding would be blocks. Once you're more like a regular coder, it'd be Java. And then if you want to take it a step further and really dive into the more complicated software aspects to it, then you would use Android Studio. Yeah.
Okay, great. Stanley had a couple questions too. So what is the optimal team size?
Okay, so right now our team is about 8 to 9 members. I know there's a lot of people in different areas. So I know we have three or four people in the business section. We have them working on outreach, how to spread FIRST around different communities. And then we have a lot of different builders. So if like someone's not here, there's always someone else to take their place. So it's always good to have not a super small team, but a bigger team, which allows for like different people to work on things simultaneously and like someone to step in if ever needed.
And a follow-up from Stanley was, in terms of time, what did you notice that worked best for your team? After school, during lunch, a class period?
We're lucky. We have like an elective dedicated to robotics. So basically every day we have like a robotics period. And so we're able to work on it for an hour. But then sometimes if we need additional times, especially like the day before a meet, we'll oftentimes stay after school. But we find that working on it during school is best because not only will like optimize the amount of team members who are able to come, but then it's also easy to like connect with like the teacher as well.
And then I know over COVID, when we were all virtual, we would have meetings at some people's houses over the weekends to work on our robots since we weren't able to work hands-on at school since it was virtual.
Yeah. Okay, Akshita wanted to know, how far did you get in the competition this year?
We made it to regionals. So yeah.
Which is essentially there's like league competitions where you compete and then those scores are carried over onto qualifiers. And then at qualifiers, if you advance from qualifiers, it's regionals. And then if you advance from regionals, it's worlds. So we got up to regionals this year.
So we were one of the 7 teams out of the qualifiers of like 40 teams who made it onto regionals. So it all depends on your like how you played that time and then like your previous scores that go over.
And then something we also like want to emphasize is like it's not just about like the just the robot itself, but then also how you're able to document your team journey. So I know something that really went well for us was our engineering portfolio. Having like a good engineering portfolio is really, really integral in like having your team being able to like advance and then make an impression on the judges, because that's who you're trying to impress at the end of the day. You want to make sure that your team spirit and your team bonding is really, really strong. And so you're able to communicate yourself well as a team and show how you got there and how your robot came to be.
And there was a follow-up question to that, which was, how did you do publicity outreach this year, demos, volunteering, etc.?
So with regards just to like, connecting to our community, so we have like a computer science honor society. And so what we did was we had essentially these like little robots are called Edison robots, and they're essentially these pre-built robots that you can program on a site. And we taught 7th grade classrooms basically how to program it. And so that was like kind of our outreach and kind of encouraging them to pursue that, interest in robotics if they had that. And then also with like the CAD or just like 3D printing. So for example, since we have a 3D printer, someone who's dedicated to 3D printing on our team, we had that person would essentially 3D print for our other teams at our school. And so that's like another way of outreach and like connecting with different teams, and also with the middle school teams, because we have a middle school robotics team. So teaching them and mentoring them if they need any help. And then sometimes they would come in when we were practicing and see what they can, what a future in FTC looks like.
We also, we've done scrimmages with other teams. So I know our other campus our other team who's on the same campus, we've had them come over and we've played with them and we've like shown them how our robotics is. We've taught them about our robot, and if they ever needed help, we were here to lend a hand.
We have a lot of more great questions in the chat here, so I can help send those to you. Do you know what the robot does? Can you explain more specifically? What does the robot really do, step by step?
So I don't know, maybe if you guys would be interested, we could show like what our season like challenge was, but essentially most of the time you have a base for your robot to drive around. That's mostly what we keep. Like during off-season time, we have a base for like drivers to practice if they want to practice off-season. And this year the challenge was to pick up these cones and put them on these like poles. You want to grab a pole? We'll get them poles. We grab these cones. Oh, we're stuck. It's okay. Well, we grab these like sort of cones. This is our own created cone that we made, which is more in the competition. Oh yeah,
these are like the
game cones.
Yeah.
And basically, we have a claw, which that's why we have 2 drivers. We have one to drive the wheels, one to grab the claw, and we have these poles that are on the field, and we basically have this claw, and they step it on, and that's a set number of points. And we have different heights, different So that's mainly like what we had our robot do this year. Past seasons, we had this really cool wheel that would spin on the robot, and we had to turn like this bigger wheel to get more points. Like it really depends every year. One year they had like you had to like shoot stuff into this like into like these nets. But yeah, this year we had a very simple like it picks up a cone, stacks it on. Just say that's about it.
Yeah. Every year is a new challenge.
But yeah, it really all depends on the season. Like we know for next season, like we're not gonna have the same design for sure. But yeah.
Amazing question. So there's more. Do you use SolidWorks? What is SolidWorks for those that don't know?
Could you guys elaborate on that? Like,
Yeah, Akshita, do you want to open your mic and help us out or put it in the chat?
Tinkercad.
Yeah. So we use Tinkercad for our 3D printing. That's like the software that we use.
Yeah.
Oh yeah, it's a CAD software.
Yeah.
I don't think we use SolidWorks. I know our 3D printer does use like Tinkercad and another one, but
Onshape. I think so.
Onshape.
We have used Onshape in the past.
Yes, but we haven't used SolidWorks. Yeah, we have used Onshape, or that's the one our 3D printer uses. And then sometimes if we want to, because she's like more advanced at designing them, but then on other works, like if any other team members want to try to design something, we usually use Tinkercad, and then she usually converts the file and everything and gets it printed like that.
And we have questions from Stanley and Lauren. So Stanley wants to know, if you recall in the past, what was the biggest hurdle in getting first started at your school? Biggest challenge?
For us, there was already a team like that had started before us, and we were really fortunate to have their support. They had already fundraised, and basically we were just getting their leftover support like from them. Do you guys have any?
I think another big challenge is like at the very beginning of each cycle when we're trying out new designs, seeing if they work or not, and then having to like either take down the whole robot and redo our design or have to elaborate and build onto it. So I think that's where like we sometimes get stuck with like design a bit, and then like making sure it's able to be programmed to like do what we want it to do.
Yeah. And then also with recruitment, because every year, like, because we're all for our team, we're all in 12th grade for the most part. And so when we graduate, what we're trying to do is like get new members and like recruit people. So like they can kind of fulfill, the Galaxy legacy, I guess. So every year it's always like a matter of just making sure that like we have like a number of people who are, on the team and recruited, and they don't graduate or they don't leave, so we can keep our team standing.
I would also say just for starting a team, like, just like knowing how to build, like learning your way around like how to code, how to like put the robots together. I mean, there's not like full guides on how to build a claw on a robot. Like you kind of have to, I mean, this year it was much easier since this is our 4th year. We've had some hurdles, we figured it out. So just like, it's not going to be easy at the beginning. Like we have suffered great losses, at the beginning, but it's just like knowing like how to build, knowing how to code. That's why we do have all separate roles, because like we all have our own specialties. So learning those skills is definitely like important.
I think that goes with Lauren's questions. First one was, how long have you been working with robotics? So I know you mentioned you're all in 12th grade, but maybe individually it's been different for you.
Yeah, so I've been on the team for 3 years, and one of those was like all online. So technically 2 in-person seasons.
Me and Anjola have been on the team for 4 years.
Yeah. What got me to like actually join was like another person from another team telling me about first. And so like that's why like emphasizing outreach is so important and getting people to join, because that's what brought me there. But there was already an interest that was like, cultivated because I went to like a summer program and did robots. But like having that person recommend that to you is so valuable. And so yeah.
Oh, I've been on the team. I joined during the virtual year as well. So I've been in 2 in-person seasons and 1 online.
Yeah. And then I've been in the team for 2 years. So I joined once we came back in person. Yeah.
And a couple more questions from Lauren. How big can your robots be? We know the competition changes every year, but how big do they get?
So the regulation stays the same. So like the rules for what can be on your robot, what can't be, stay the same even throughout all the seasons. So it's 18 inches by 18 inches, and our robot has to stay within it. There's no weight limit on it, but there used to be in past years, but they removed it more recently. So we don't have a weight limit. It just has to fit within our 18-inch by 18-inch.
And then I know since we're FTC, FRC, so First Robotics Challenge, has different guidelines for their robots. So their robots tend to be much bigger on a bigger scale. I'm not sure the exact dimensions, but I know they're like 2 or 3 times bigger than FTC's robots.
And I guess the size regulations don't really like, there's ways around it. Like a lot of teams have extendable like claws or like pieces. So as long as it at one point can fit in those regulations, like for instance, we have a claw and we open it all the way so it fits inside the 18 by 18. But like after that like regulation check, it like after the round starts, we're allowed to like have it close and like go past that 18 by 18. Yes. So there's a lot of like, I just remember my first year, there was a team that had, there was like this rule where like you had to park at the end of the match, and there was this one team that had a tape measure, or yeah, I think it was a tape measure, and it would extend to park, because as long as the robot was like in that, like touching that area, that like counted. Yeah. So there's a lot of like cool tricks you can, or I don't know, outside of the box thinking you can do, like even with those regulations. Yeah.
So if you're new to robotics, where can you start if you're interested?
Yeah, so if you go to FTC's program, if you don't like have the materials to start a team, or you don't know a lot of people that want to be in robotics, if you go to FTC's website, there's a place where you can join teams. And even if you search teams like online, like, or like if your parents go like on social media, then you can find teams that are recruiting. So you don't specifically have to start a team. But like if you're interested in starting a team, we definitely recommend it. It's amazing. But if you're not interested in starting a team, but you want to be part of robotics, you can just go online and find teams that are recruiting, and then you can join teams that already exist.
Is that true even if it's not at your school? You could join a team at another school. Okay.
There's community teams and there's school-based teams. So school-based teams are usually just within schools, but we compete with a lot of community teams which aren't school-based, and they're like all just working either at like someone's house, at like a public place, and they're all from like different schools, and they just come together to form a community team.
And how do you balance all of this? How do you balance school and other activities that you do with robotics? You're very busy people.
I know, at least for me, the meets are very long. They're probably from 8 a.m. to 5 p.m. and it's an hour drive there. So a lot of time commitment, especially on the weekends. So Saturdays, you basically can't really plan to do anything else. You're going to be there the whole day.
It's tiring. Yeah.
But meets are only like once a month.
Yeah. So you just have to be able to do those and give time to robotics.
Yeah. And I mean, we're lucky to have like to be able to partake in robotics during school. So we do have that set hour 4 times a week. Yes. So we definitely take that time. If we need more time, I mean, that comes with our schedules. So, I mean, if we don't have time, we don't have time. If we do, great. It's different for everybody, especially, you know, we're high schoolers. I mean, up to elementary school, you can be doing robotics. So it really just depends.
Yeah. And I think that's also why it's really important to set deadlines and goals. Like you can set a goal of, oh, I want to spend this much time. I want to dedicate this much time to just robotics. And then that helps you get along with that goal. And you can set deadlines like, oh, by this date, I want to have this done. So it's balancing those deadlines and then balancing schoolwork at the same time, just making sure that they don't overlap. I know I have a calendar where I would put like, oh, this program needs to be done by this date, and then this needs to be turned in by this date. And then I'll try to schedule it depending on my classwork, depending on like when my essays were due, well, like when I had a calculus test, like, so it's making sure you can like schedule things around. I would definitely recommend, especially if you think you're gonna have trouble balancing it, to get a calendar, whether it's an online one or like a physical one, and to be able to like actually plan out how your days are gonna look, because it's really helpful that way.
There was a question from Sam and a little confusion. So USC does not have robotics teams. We're just hosting events this week for Robotics Week. You are a high school team. So Sam's question is about if you know about another team and you want to beat them in a competition, what are some of the best teams out there and you really want to beat them? How do you do it?
Well, I think on that, like, it really depends. You can't really set out to join a robotics team just to be another team, especially because of how FTC is formed around gracious professionalism. So basically, in the competition, you're randomly assigned a partner that you share the field with, and they're your partner for that round, and then you play the game against two other partners. But then in the next round, that person might be the person you're going up against. So even if you set out to beat a team, like walking into the competition, you don't know if you're going to be against them or if you're going to be partnered with them. So it's hard to like have that mentality of I just want to like go against this team, because gracious professionalism teaches us to like be friendly to all the teams, because they can be a competition, yeah, but they could also be your partner that can help you like make it to the next round.
Yeah.
Stanley really loves that phrase that we learned today, gracious professionalism. Were you going to say a little more about that?
Yeah, I can talk a little bit more about it. It's sort of like the key like function of FTC. Like,
it's like their motto.
Yeah, it's like their motto.
Yeah.
Like they always emphasize gracious professionalism, which is like working with people even if you're competing against them, which is why like the competition is set up that way. You can be someone's partner and then you could go against them. You can go against someone and they could like defeat you really badly, and then you're like, oh, I can't believe I got defeated by this team. But then they'll be your partner the next round, and you know that's an amazing team to be partnered up with. So I know even when we went up against teams and we couldn't beat them, we'd be like, we wouldn't think more of like, oh, I have to beat them. It'd be more like, oh, I want that person to be on my team. I want to be partnered up with that team because I know how great they are, which is sort of what gracious professionalism has taught us, so that like teams don't go against each other, but instead they try to help each other.
And then I know a lot during the meets, like if our robot's broken or
Yeah.
we can't fix something, like one time our string broke and someone from another team came running over to help us.
Yeah.
So it's very collaborative environment, especially within the teams. Like we all know everyone's robot's going to malfunction at one point. So we all just help each other the best we can. And it's really good, like great to see everyone collaborating, especially if they're from different schools or you don't even know them. Like they're just next door. You can ask, hey, do you have any extra tape or like any extra materials that we might need? And it's very collaborative and helpful.
And another thing about gracious professionalism, another part to the competition is picking alliances.
Yeah.
Semifinals and finals, you are the top teams. So you normally get a randomized alliance, but once you make it to the semifinals, you get to pick your alliance. So often the higher ranked teams will pick high ranked other teams, or I mean, that your gracious professionalism can influence that. Yeah. There may be better teams, but there may be teams, I don't know, that work well in specific areas that, maybe they didn't do well during the competition, but oh, I know this team because that's part of the gracious professionalism and scouting and just meeting the teams while we're preparing for those competitions. And that's all part of strategy, picking the best alliances to work